The National Electrical Code, or NEC, serves as a foundational set of safety standards. Its primary objective is to prevent electrical fires and other potential hazards that may arise from electrical systems. It is important to understand that the NEC is not designed to protect against all possible abnormal conditions that could develop within an electrical system. The NEC scope is focused on addressing more common electrical hazards rather than attempting to cover every conceivable rare occurrence. For example, the NEC does not mandate the use of surge protection devices to safeguard against voltage spikes. The rationale behind this is that voltage spikes are considered to be relatively infrequent events, and the NEC prioritizes protection against hazards that are more prevalent. Similarly, the NEC does not require the installation of open neutral detectors to provide protection against open neutrals. While open neutrals occur more frequently than voltage spikes, they are still considered to be relatively uncommon. In most cases, an open neutral will not pose a significant safety hazard, as it typically results in the affected circuit tripping, effectively shutting down the power supply. However, there are specific scenarios in which an open neutral can potentially create a safety hazard. For example, if an open neutral develops on a circuit that is supplying power to a ground fault circuit interrupter or GFCI outlet, the GFCI outlet may not function correctly or trip as intended. This malfunction could create a risk of electrical shock. To mitigate this risk and ensure electrical safety, it is crucial to be aware of the potential for open neutrals to occur. Implementing preventative measures and safety precautions can significantly reduce the likelihood of hazards. These measures can include the use of surge protection devices to protect against voltage spikes, which can sometimes contribute to neutral problems. Additionally, the installation of open neutral detectors can provide an early warning system, alerting to the presence of an open neutral condition and allowing for timely intervention. In summary, while the NEC does not explicitly address every possible abnormal condition such as open neutrals, understanding the potential risks and implementing appropriate safety measures is essential for maintaining a safe electrical system. Electrical systems are designed to operate within specific parameters, and any deviation from these parameters can potentially lead to hazardous situations. Open neutrals are one such condition that can disrupt the normal functioning of a circuit and create safety risks. Firstly, let's define what an open neutral is. In a typical electrical circuit, the neutral wire provides a return path for the current to flow back to the source. When the neutral wire is disconnected or broken, it creates an open circuit condition. This open circuit disrupts the normal flow of current and can cause voltage imbalances and other electrical problems. Secondly, the consequences of an open neutral can vary depending on the specific circuit and the load connected to it. In some cases, the circuit may simply stop working, while in other cases, it can lead to overvoltage conditions and equipment damage. For example, if an open neutral occurs in a multi-wire branch circuit, it can cause the voltage to shift unevenly between the different legs of the circuit. This can result in some devices receiving too much voltage, while others receive too little, potentially damaging sensitive electronic equipment. Thirdly, one of the most significant safety concerns associated with open neutrals is the risk of electric shock. In a properly grounded electrical system, the neutral wire is connected to ground, providing a low impedance path for fault current to flow back to the source. This helps to quickly trip the circuit breaker or fuse in the event of a ground fault, protecting against electric shock. However, when the neutral wire is open, this grounding path is compromised and the risk of electric shock increases. If a person comes into contact with a live conductor and a grounded object, the current may flow through their body instead of back to the source, resulting in a potentially fatal electric shock. Fourthly, to mitigate the risks associated with open neutrals, several measures can be taken. One important step is to ensure that all electrical connections are properly made and tightened. Loose connections can create a higher resistance point in the circuit, which can lead to overheating and eventually cause the neutral wire to break. Regular inspections of electrical panels and wiring can help to identify and correct any potential problems before they become a safety hazard. Fifthly, another effective measure is to install ground fault circuit interrupters or GFCIs in areas where there is a high risk of electric shock, such as bathrooms and kitchens. GFCIs are designed to detect even small amounts of current leakage to ground and quickly trip the circuit, preventing electric shock. While GFCIs are not specifically designed to protect against open neutrals, they can provide an additional layer of protection in the event of a ground fault. Sixthly, open neutral detectors are also available, which can be installed to monitor the neutral wire and provide an alarm if an open neutral condition is detected. These detectors can be particularly useful in critical applications where the consequences of an open neutral could be severe, such as in hospitals or data centers. Seventhly, surge protection devices or SPD can also help to protect against voltage spikes, which can sometimes contribute to neutral problems. Voltage spikes can occur due to various factors, such as lightning strikes, power surges, or switching of electrical loads. These spikes can damage sensitive electronic equipment and can also weaken the neutral wire, making it more susceptible to breakage. Eighthly, the NEC provides specific requirements for the grounding and bonding of electrical systems to minimize the risk of electric shock and other hazards. These requirements are outlined in Article 250 of the NEC, which covers topics such as grounding electrode systems, equipment grounding conductors, and bonding of metal enclosures. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. Ninthly, regular maintenance and testing of electrical systems are also essential for identifying and correcting any potential problems. This includes testing the continuity of the neutral wire, checking for loose connections, and inspecting the grounding system. By performing regular maintenance and testing, it is possible to identify and correct any potential problems before they become a safety hazard. Tenthly, in addition to the measures mentioned above, it is also important to educate people about the risks associated with open neutrals and how to prevent them. This includes teaching people how to properly use electrical equipment, how to identify potential hazards, and what to do in the event of an electrical emergency. By raising awareness about electrical safety, it is possible to reduce the number of accidents and injuries caused by electrical hazards. In conclusion, while the NEC does not specifically address every possible abnormal condition such as open neutrals, understanding the potential risks and implementing appropriate safety measures is essential for maintaining a safe electrical system. By following the requirements of the NEC, performing regular maintenance and testing, and educating people about electrical safety, it is possible to minimize the risk of electric shock and other electrical hazards. It is important to remember that electrical safety is everyone's responsibility, and by working together, we can create a safer environment for ourselves and others. The NEC is a comprehensive document that provides guidance on a wide range of electrical safety topics. It is updated regularly to reflect the latest technological advancements in safety practices. It is important for electrical professionals to stay up to date on the latest changes to the NEC to ensure that they are providing the safest and most effective electrical installations. The NEC is not a static document, but rather a living document that evolves over time to meet the changing needs of the electrical industry. By staying informed and following the requirements of the NEC, electrical professionals can help to ensure that electrical systems are safe and reliable. The purpose of the NEC is to protect people and property from the hazards of electricity. It is a set of minimum safety standards that are designed to prevent electrical fires, electric shock, and other electrical hazards. The NEC is not intended to be a design manual, but rather a set of safety requirements that must be followed when installing electrical systems. It is the responsibility of the electrical professional to design and install electrical systems that meet the requirements of the NEC and are safe for the intended use. The NEC is a valuable resource for electrical professionals and anyone who is involved in the installation, maintenance, or repair of electrical systems. By following the requirements of the NEC, it is possible to minimize the risk of electrical hazards and create a safer environment for everyone. It is important to remember that electricity is a powerful force that can be dangerous if not handled properly. By following the requirements of the NEC and taking appropriate safety precautions, it is possible to harness the power of electricity safely and effectively. The NEC is a tool that can be used to protect people and property from the hazards of electricity. By using this tool wisely and responsibly, it is possible to create a safer and more reliable electrical system for everyone.